Hello everyone, welcome back to my channel. So in this video we'll solve some of the problems based on Cauchys residue theorem. Okay, so Cauchys residue theorem. If you are first time to my channel, please consider subscribing and encourage me to do more videos like this. So Cauchys residue theorem, what does it tell you? Cauchys residue theorem is integral C f of z dz, that is, this integral evaluation is 2 pi I into sum of residues at poles. Okay, so at different poles you have to calculate the residues using residue formula, and that integral is given by 2 pi I multiplied by sum of residues. Right, so here z is equal to 1 is simple pole, right? Z is equal to 1 is a simple pole, and z is equal to 2 is pole of order 2. So in order to evaluate or in order to apply residue theorem, the poles must lie inside the contour. Okay, same we have seen the same rule when we are solving the problems for Cauchys integral formula. So they should lie inside the given contour. So first of all, z minus 2 minus 1 by 2 will solve for z is equal to 1. So it will be 1 minus 2 minus 1 by 2. So it will be 1 minus 1 by 2, which is equal to 1 by 2. 1 by 2 is greater than 0. So it lies outside the contour. Okay, it lies outside the contour. So that is the thing. Next, z minus 2 minus 1 by 2. So z is equal to 2 if you substitute. So 2 minus 2 is 0, minus 1 by 2. 0 minus 1 by 2 is minus 1 by 2 less than 0. So this lies inside the contour. When one pole lies outside and the other pole lies inside, what you have to do? You have to shift the pole which is outside to the numerator so that it will be a part of function f of z. So z by z minus 1 you have to write, divided by z minus 2 whole square into dz. So now for this we can apply Cauchys residue theorem. Okay, right. So first of all, so what is Cauchys residue theorem? So integral C, this z by z minus 1 divided by z minus 2 whole square dz is equal to, by Cauchys residue theorem, 2 pi I into residue of f of z at z is equal to 2. Okay, so now we have to find this value, residue of f of z at z is equal to 2. So the z is equal to 2 is a pole of order 2. So residue of pole formula is residue of f of z at z is equal to z naught is 1 by m minus 1 factorial, m is order of the pole, d power m minus 1 by dz power m minus 1 into z minus z naught whole to the power of m into f of z. Okay, so now I am finding the residue of f of z at z is equal to 2 is equal to 1 by 2 minus 1 factorial. So 1 by 1 factorial d by dz, m is 2, so 2 minus 1 is 1. So d by dz of z minus 2 whole square into f of z. F of z is z by z minus 1 into z minus 2 whole square. So z minus 2 whole square, z minus 2 whole square gets cancelled off. So 1 by 1 factorial is 1 only, so it will be, sorry, limit is there, no? Limit as z tends to z naught. Z naught value is 2 here, right? So limit as z tends to 2 d by dz of z by z minus 1. So this is of the form u by v. So this is u v. So u dash v minus v dash u by v square. So I am doing that directly, right? U dash means dou by dou z of z, which is 1, into v is z minus 1, minus v dash is 1 into z divided by z minus 1 whole square. So limit as z tends to 2, so z minus 1 minus z divided by z minus 1 whole square. So plus z minus z gets cancelled. So limit as z tends to 2 minus 1 by z minus 1 whole square. So if you substitute 2 minus 1 by 2 minus 1 whole square is 1, so you'll get minus 1. So this residue value is minus 1. Therefore integral C f of z dz, that is this total f of z dz is 2 pi I into minus 1, so its value is minus 2 pi I. Okay, so this is how we can solve by using Cauchys residue theorem. So if you solve this using Cauchys integral formula, CIF also, so integral C z by z minus 1 divided by z minus 2 whole square dz, because we have already found z is equal to 1 is outside, so when it is outside we are going to write this. So 2 pi I by n, so n plus 1 here is 2, right? In the formula n is equal to 1, so 1 factorial into f dash of 2. So f of z is equal to z by z minus 1, right? Z by z minus 1. So f dash of z, if you want to find, it is u dash v minus v dash u by v square. So minus 1 by z minus 1 whole square. So f double dash of at z naught you have to find. So z naught is 2 now. So it will be 2 pi I into f dash of 2. So f dash of 2, this is f dash of z. So it will be 1 by minus 1 by 2 minus 1 whole square. So it will be minus 1. So if you substitute 2 pi I into minus 1, which is equal to minus 2 pi I only. So you can solve this problem using Cauchys integral formula, or you can solve using Cauchys residue theorem. Okay, so both the results are same. You'll get minus 2 pi I in both the cases like this. Okay. So next we'll see the second problem, right? So evaluate this integral where c is given as z is equal, mod z is equal 3 by 2 using residue theorem. Okay, so if you observe f of z, z is equal to 0, z is equal to 1 and z is equal to 2 are simple poles. Okay, so mod z is equal to 3 by 2 is the pole here. So z is equal to 0. So mod z minus 3 by 2, that is 0 minus 3 by 2, which is equal to minus 3 by 2 less than 0. So it is inside. Z is equal to 1. So when z is equal to 1, mod z minus 3 by 2. So 1 minus 3 by 2, which is equal to minus 1 by 2, which is less than 0. So this is also inside. So z is equal to 2. Mod z minus 3 by 2. So 2 minus 3 by 2. So 4 minus 1. So 1 by 2, which is greater than 0. So this is outside. Right? So this is outside. Therefore, integral C 4 minus 3z by z minus 2 divided by z into z minus 1 dz is equal to, so integral of this is equal to 2 pi I into sum of residues. Sum of residues. What is that sum of residues? 2 pi I into residue of f of z at z is equal to 0 plus residue of f of z at z is equal to 1. Okay, so this is the value of the given integral. Okay, so now we will find the residues first. So all are simple residues only. So residue of f of z at z is equal to 0 is limit as z tends to z0 is 0. So z minus z0, z minus 0 is z only into f of z. So 4 minus 3z by z minus 2 divided by z into z minus 1. So z and this z gets cancelled off, right? So if you substitute z is equal to 0, what you'll get? So 4 minus 3 into 0 is 0 only. 4 by minus 2. Okay, z minus 2. 0 minus 2 is minus 2 divided by 0 minus 1 is minus 1. So it will be minus 2 by minus 1, which is equal to 2. Similarly, residue of f of z at z is equal to 1. So is limit as z tends to 1, z minus z0, z minus 1 into 4 minus 3z by z minus 2 divided by z into z minus 1. So z minus 1 gets cancelled off. If you substitute z is equal to 1, so 4 minus 3 is 1 divided by 1 minus 2 is minus 1 divided by 1 again. So minus 1 by 1, which is equal to minus 1. Therefore integral C, okay, so 4 minus 3z by z into z minus 1 into z minus 2 dz is equal to 2 pi I into residue of f of z at z is equal to 0 is 2 and residue of f of z at z is equal to 1 is minus 1. So 2 minus 1 is 1. 1 into 2 pi I is 2 pi I. Okay, so this is the answer. Very simple. So if you are very good at finding the residues, just you have to find the poles which are lying inside the given counter in the given contour, and then you just have to find the residues and take sum of residues multiplied by 2 pi I as per residue theorem. Okay. So next we'll solve one more problem on this residue theorem. So he has given like this. So find the value of this with the closed contour given by z plus 1 plus I modulus is equal to 2. Okay. So poles will be z square plus 2z plus 5, okay, is equal to 0. So it will be z plus 1 whole square plus 2 square is equal to 0. Z square plus 2z plus 1. So z square plus 2z plus 1 plus 4 we can write. So this one, the three terms is z plus 1 whole square plus 2 square. So that's what I have written here. So z plus 1 whole square is equal to minus 2 square. So z plus 1 is equal to plus or minus 2i. So z is equal to minus 1 plus or minus 2i. So z is equal to minus 1 minus 2i is one pole, minus 1 plus 2i, both are simple poles only. Okay, so now we have to find whether they are inside the contour or not. So first of all I am taking z is equal to minus 1 minus 2i. So modulus of z plus 1 plus I minus 2. So modulus of what is z? Z value is minus 1 minus 2i plus 1 plus I minus 2. So plus 1 and minus 1 got cancelled. So minus 2i plus I is minus I minus 2. So modulus of minus I is 1 minus 2 is minus 1, which is less than 0. So it is inside the contour. So similarly z is equal to minus 1 plus 2i if you consider. So minus 1 plus 2i plus 1 plus I minus 2. So minus 1 plus 1 gets cancelled. So modulus of minus 3i, sorry, modulus of 3i minus 2. Modulus of 3i is 3 minus 2, which is equal to 1, greater than 0. So this is outside the contour. Outside the contour. So we can write integral C z minus 3 divided by z, how can we write this? Z plus 1 plus 2i, z plus 1 plus 2i into z plus 1 minus 2i, z plus 1 minus 2i dz. This also can be written as integral of C. This z is equal to 1, z is equal to minus 1 plus 2i, that is z plus 1 minus 2i. So this pole is outside the unit circle. So this pole has to be sent to the numerator in order for application of CRT. Right, so this can be written as z minus 3 by z plus 1 minus 2i divided by z plus 1 plus 2i dz. Okay, this value is equal to 2 pi I into residue of f of z at z is equal to minus 1 minus 2i. Because only one residue is there, so sum of residues means only one residue. So if you find this value and multiply it with 2 pi I, that is your answer. Okay, so we are finding residue of f of z at z is equal to minus 1 minus 2i. Simple pole only, so limit as z tends to minus 1 minus 2i into z plus 1 plus 2i into z minus 3 divided by z plus 1 minus 2i divided by z plus 1 plus 2i. So this and this gets cancelled off. So substitute minus 1 minus 2i. So minus 1 minus 2i. In the place of z, you have to substitute with minus 1 minus 2i. Minus 3 divided by minus 1 minus 2i plus 1 minus 2i. So this will be minus 4 minus 2i divided by plus 1 and minus 1 gets cancelled. So it will be minus 4i. So it will be 4 plus 2i divided by 4i, right? So it will be 1 by 2 plus 1 by I. 1 by 2 plus 1 by I. Okay, so 2i by 4i. 2i by 4i is 1 by 2 and 4 by 4i is 1 by I. Right, so integral of c z minus 3 divided by z square plus 2z plus 5 dz is equal to 2 pi I into this residue value 1 by 2 plus 1 by I. So it will be pi I. So 2 and 2 gets cancelled. So in the first term, I am talking about the first term. So 2 pi I into 1 by 2 is pi I plus 2 pi. 2 pi I into 1 by I and I gets cancelled, you will get 2 pi. So pi into I plus 2. Okay, this is the answer. Right, so this is how we can solve any problem using Cauchys residue theorem. Okay.